Okay, in this video, we're going to talk about lines, how to graph them, and the different forms lines can be in. All right, so this is section 2 from Math 100. In college algebra, it's in chapter 3, but the concepts are exactly the same. So remember the linear equation ax plus by equals c, right? That is what we call the standard form of a line. And so if we want to graph it, I created an XY coordinate that goes from -8 to 8. And so look at the x-axis, the horizontal, which we typically call x, right? And look at it just like a number line. So the center here is the origin, and that is the point 0, 0. So if 0 is here in the middle, right? So negatives go to the left, positives go to the right. Well, the y-axis is still 0 in the middle. Negatives go down, positives go up, and just like the alphabet, when you go to put a point in, it is x, comma, y. X becomes before y, so x is first. Anytime you do a point, it is parentheses, an x and a y. A lot of times I get people complain that the computer software is too picky. If we do this on paper and you did it on a test, I would also take points off. A point is a parentheses with a comma, 2 values, right? So, and if we look at this, right, it kind of goes counterclockwise like a clock. So, no, I don't want to do that. We have our quadrants. So each one of these are called quadrants. Quadrant. So this is quadrant 1. Back here is quadrant 2. And then down here is quadrant 3 and 4. So let's stop that. Quadrant 3 and quadrant 4. And so if we are in quadrant 1, our values are always going to be positive. So my x will be a positive and my y will be a positive. Both values are positive. Quadrant 2 is x is negative, y is positive. And quadrant 3, they're both negative. In quadrant 4, x is, oops, not, I wrote x is x. But x is positive and y is negative. Lost my why is it doing that? It's erasing everything. Let's write over it. Positive and negative. So that's important because when we go to look at slopes and stuff, if we know if we're going from in this direction, my slope is positive because 2 negatives make it positive and I'm positive. So if I am going in that direction, I am positive. And if I am, my slope will be negative if I am going from the top left to the bottom right. And so those are kind of some neat tricks to help make sure that we're on the right track here. All right, so I'm going to show some graphing using Excel. You don't know how to use Excel. When you go to use your Pearson software or Hawks, it will graph for you. But Excel is a nice visual to make that'll draw things to scale, because you're going to see that I do not draw things to scale very well. So some steps to graphing. First, build an XY table. All right, so I'll get the table built below. The book says to arrange your values in order. It's not necessary. It's a neat thing. Draw your X and Y axis and make sure you always label and plot the points and then connect the dots. Right, so here's our equation in standard form. 1 equals 2/3 X minus Y. So do a couple practice algebra questions over here on the side. And then we will use Excel to do the rest. So 2/3. So in the first case, X is 6. Minus the Y, right? So, and we're gonna have to get comfortable with fractions because most slopes are fractions. So I picked 6 on purpose because this 3 can go into this 6 twice. So then I get 1 minus, not 1 minus, 1 equals 2 times 2 minus Y. 2 times 2 is 4, so 1 equals 4 minus Y. Subtract 4 from both sides. -3 equals -Y. And then I divide through by -1 to get the Y to be positive. Y equals 3. Right? And if we want to do another one, right? So the 0 is, well, we'll do the 3 first. So 1 equals 2/3 times 3 minus Y. And this is good to understand how fractions work because when your homework asks you to pick points in your fraction, most pick things where they cancel because then this 3 and this 3 cancel. So I get 1 equals 2 minus Y. Subtract 2 from both sides. -1 equals -Y. Again, divide through by your -1s. And Y equals 1. If I put 0 in, this all goes away, and I get Y, 1 equals -Y, divide through by -1, and then I get a Y equals -1. And then just for time, you can do these two on your own if you want to see it, but they are -3 and -5. So now I want to draw my XY coordinate. There's my Y, there's my X. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So to plot our first point, we'll do this one in red. I go over 6. I guess I should have one more. We'll have the 6th one. Go over 6 from the origin. So 1, 2, 3, 4, 5, 6, up 3. And there is the first point. To do my second point, I start at the origin, go over 3, up 1. To do this point, I am at 0. So I don't go left or right at all, but I go down 1. This is a specific point. This is called the y-intercept. Anytime x is 0, and I get y as a number, that is the y-intercept because it is where the point is on the y-axis. Right, and then we can graph this point. We'll do it as a little square just so we can be different since it's the same color. We go over -3, so we go to left 3, down 3, and I'll put a little square. And then we'll do a blue one. No, we can do black. That'll be easier. A black dot over -6, down -5. And not too bad for not having things drawn to scale. And I know I cannot draw straight lines, but we'll do the best we can here. Try and draw a line through these dots. And there is our line by using the graphing table method. So now we come down to this problem. I draw my x and y axis again. Y, draw a little further out. X, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. And you can pick any numbers you like when you're doing these or make as many ticks. Like I said, the good news with the homework, it'll be done for you. So here is our new equation, 2x plus 3y equals 12. All right. I like to always try to find the intercepts. So again, when x is 0, that is the y-intercept. However, when y is 0, that is the x-intercept. That is where the line crosses the x-axis. And so if I put 0 in here, I get 2x equals 12, because the 0 cancels out the y. This is why I always like to use the intercepts. I quickly get rid of part of the equation, divide by 2, and x equals 6. Now if I do x is equal to 0, now he's gone, and I get 3y equals 12. Divide by 3, y equals 4. Now you should always, so all you need is 2 points to graph a line. So go over 6, 1, 2, 3, 4, 5, 6, 0. There is my x-intercept. Go over 0 up 4. There is my y-intercept. And you only need 2 points to graph a line. I'm not really drawing, just I missed it a little bit. However, I always encourage people to do at least 3 points. Because if all 3 points fall on the line, then you are pretty much guaranteed to be correct, right? So if x is 3, so we get 2 times 3 plus 3y equals 12. 2 times 3 is 6, plus 3y is 12. Subtract 6 from both sides. I get 3y equals 6. Divide by 3. 6 divided by 3 is 2, so y is 2. So if I go over 3, 1, 2, 3, I go up 2. And I am on the line. Now I have all 3 points. So 2 points to graph a line, 3 points to make sure that your line is correct. All right, so real quick, just to show how Excel can do these. I've already built our little thing in Excel. Well, I gotta do new share. I built our little table that we had before. So I listed out my x's and the y's, and there is the line. It looks just like we draw. Now it's on a scale. Now if I change out the numbers from the new one, so we had 6, 3, 0, 3, and then I had a 5 on my OneNote. You can pull up the OneNote to see it. Then my y was 0, 2, 4, 6, and 2/3. Well, Excel likes to do things as a date. So 2/3 is 0.666666 repeating. And it still thinks it's a date. This is where Excel can be tricky when you're first learning how to use it, because it thinks it's smarter than you and it wants to make things what they are not. So let me fix this and turn this into a fraction. There we go. And now we have our line, which was very similar to the one we had before. So Excel is a nice way to draw things to scale. When you do your homework, it will do this for you. You'll put your points in, and it will draw the line for you. So back to our OneNote. I want to show that we can draw things to scale fairly easily. There we go. So another equation of a line is what we call slope-intercept form. That is y equals mx plus b, which most of us have probably have done stuff with lines before know this to be a line, right? So m is our slope, and b is our y-intercept. So just like we learned before, the value b is our y-intercept. So b is a point where the line crosses the y-axis where x is 0. This is called the y-intercept. It is a point. So when you put it in, it is the point x is 0, and the y value is whatever b is. It is a point. You must put in parentheses. You must put in 0 for x. You must put in a comma. And the x-intercept is when y equals 0 and across the x-axis, like we said before. Now, and we drew it with these, so that's fine. I'm gonna take clear. Here's my OneNote, that way my stuff goes with it. So when I have 2 points, I can easily just graph them, right? So if I go back to my draw and I put my graph out here, y and x, 1, 2, 3, 4, 5, 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So now I can graph this thing by going over 5 up 0. So 1, 2, 3, 4, 5, 0. And then my y-intercept is go over 0 down 3, right? So this is my y-int because x is 0. And this is my x-int because y is 0. It's kind of backwards. Whatever value is 0, you find the other thing. And again, wow, I was way off of my drawing that time. Still not the best. So now you can see, though, horrible draw line, but I have a line. But what if it asks you for what the equation is? Well, to find the equation, we have to use the slope formula, which is y2 minus y1 divided by x2 over x1, right? So to find slope m, we will use that equation. So m equals y2, which is -3, minus 0, all over x2, which is 0, minus 5. Put in everything in parentheses to make sure we don't mess up our order of operations. So -3 minus 0 is -3. 0 minus -5 is -5. And negative over negative is a positive, so my slope is 3/5. And the reason slope helps us is because a lot of us know slope as rise over run, right? Rise over run, where rise is the y, run is the x. So if I go to a point, this point right here, and it says rise 3, so I'll go up 3, 1, 2, 3, and then run, it's a positive 5, so I run to the right, 1, 2, 3, 4, 5. Notice I am back where I'm at. So I can do that again, up 3, 1, 2, 3, over 5, 1, 2, 3. Not drawing a scale, but it would be somewhere over here again because I didn't draw a good line. But I can quickly plot points once I know my slope. Every point is up 3 over 5 from each other. So that's why it's good to know the slopes, right? So what if we found this slope? 4/5 minus, well, let's go back to this Fisher's problem, sorry. So remember, y equals mx plus b. M is the slope. So this equation is y equals my slope, 3/5 x plus b, right? But remember, b is the point 0, and that's my b value right there, and my b value is -3. So there's my equation of my line. Now, you can only jump to the answer real quick if you know the y-intercept. If you do not know the y-intercept, we'll do that new equation here in a minute. But I want to do a few more things with slope first. So what if we had these points, 4/5 and 1/3, right? So m. Now, the formula says to do y2 minus y1, x2 minus x1. It does not matter as long as you're consistent. So if I follow the formula, y2 is 3, because my second point, minus y1, which is my first point, so 3 minus 5. You gotta make sure you keep your y's together and your x's. Usually if someone gets slope wrong, they've got their things mixed up. And then x2, which is 1, minus 4. That's my x1. So 3 minus 5 is -2. 1 minus 4 is -3. 2 negatives make it positive, so my answer is 2/3. But what if I swap them? What if I do y1 first? So 5 minus 3 over 4 minus 1. I just swap the places, and I still get 2/3. The key is you must keep your points aligned. Here was point 2 on top of each other, and here is point 1 on top of each other. Here is point 1 on top of each other over point 2 on top of each other. Just keep your points aligned going up and down. Y is always on top, and as long as you don't mess up your arithmetic, you'll always get the right slope. All right. So what does a negative slope tell me? So if I didn't change this to positive and I left it as a negative, that means I could go down to left 3, which would also still work. So let's do this one. So 5/3 and 2/3, 5/3 and 2/3. So again, my slope equals my y's subtracted over my x's subtracted in parentheses. 3 minus 3 is 0. 5 minus 2 is 3. Uh-oh, we have a 0 on the top. Well, 0 divided by 0 divided by anything is just 0. So my slope is 0. So what does that mean? Well, it means I'm not going anywhere. I'm not going up and down, right? Because that was my zeros on top. No rise over run. So my y, x, and if I just plot these 2 points, so 1, 2, 3, and then 1, 2, 3, 4, 5. So my first point is 5, 3. My second point is 2, 3. And notice it is just a horizontal line at 3. Anytime I have a slope of 0, it's a flat line, and it crosses the y-axis at whatever value the y is. So the equation is y equals b, which in this case means y equals 3. And a lot of people want it to be x because it's a flat line like the x-axis. The reason it's not x is I don't care what x is, because x is everywhere on this line. There's infinite x values. X is everywhere. All these are x values if I go down. All different types of x. The key is y has to be 3. So when we write our equation, I don't care what x is. I care that y is 3. If we do another one, m again. So y's 1 minus 3 all over 3 minus 3. It's supposed to be a 3. Gives me a -2 over 0. You cannot you cannot divide by 0. This is why it means to be undefined. However, if I plot this thing still, right, because a lot of people are like, oh, undefined, I can't do anything. Well, we still can do stuff mathematically. We just got to think about it for a minute. So again, we have our points 1, 2, 3, 1, 2, 3. So my first point, x is 3, so I go over 3, up 1. My second point, x is 3, and I go up 3. And now you notice I have a line that goes straight up and down. So in the book, it calls it x equals a, but really it's wherever the x value is, right? In this case, they're both 3's. So x equals 3. And again, people want it to be y because it's going up and down, but I don't care what y is because there's infinite y values. I can come over here and keep finding new y's over and over again. However, there is only one x value, and that x value is 3. So a straight up and down line is x equals where it crosses the x-axis, the x-intercept. If it has a slope of 0, it is y equals wherever it crosses the y-axis. Whew. All right. Last thing I want to talk about is the formula point-slope form. And the reason it's called point-slope form, well, it has the slope, m, but then it has a point, y1, x1. So if we know this line has a slope of 1/2 and it goes to the point 2, 4, what is the equation of the line? Well, now I just substitute these things in. So remember, y and x are variables, so don't touch them. But y minus y1, I'll leave that blank for a minute, equals m. Well, the slope is 1/2, so I just put 1/2 there. X minus x1. So now I'll go from my point. Remember, my y value is always the second number, so this is going to be -4. And then my x value is the first number, so that is going to be -2. And there's the equation of my line. Now, a lot of people want to keep going. If the thing asks for it to be in a certain form, then yes, keep going. But if it just asks for the equation of a line, that is the equation of a line. If it asks for it in slope-intercept form, if it wants the answer as y equals mx plus b, well, you do that by solving for y. So first thing you do, distribute the 1/2 through. So 1/2 times x is 1/2 x. 1/2 times -2 is -1. And then add 4 to both sides to get y by itself. -1 plus 4 is 3, so my equation is y equals 1/2 x plus 3. And if I want to graph that, there we go. Y x 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 4. Okay. I really need to just paste graphing paper on it. It'd be so much easier. But anyway, so, well, we already know 0.24, right? So go over 2, up 4, right? And then my slope says 1/2. So I can go up 1 over 2. Or I can go down 1 and to the left 2. And notice, this point, I'll change it to blue, is my y-intercept, which is where this 3 is. That's the point 0, 3. And there is the equation of my line. Graph of my line. All right. So the final concept I want to talk about. 2 lines are parallel if they have the same slope. 2 lines are perpendicular if the slope of one line is the negative reciprocal of the other, right? So if I have the equation y equals 1/2 x plus 3, a line that is parallel to that is y equals 1/2 x plus 7. So if I want to graph, so we already got this first line graph. I want to graph the other line. Well, I just come up here to 7. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Extend my graph here a little bit. No, my y is right in the middle. That's all right. So remember, the 7 is my y-intercept, so that is the point 0, 7. So I come up here to 7. So 1, 2, 3, 4, 5, 6, 7. Which I got 1, 2, 3, 4, 5, 6, 7. Yeah, right there. And my slope's still 1/2, so I go up 1 over 2. Up 1 over 2. And there is my parallel line. Two lines being parallel mean they never cross, and they can never cross if they have the same slope. To be perpendicular means the two lines cross at a 90-degree angle, right? So the slope of the is what they call the negative reciprocal. I just say flip the slope, change the sign. So a line that is perpendicular to our original equation, this guy, I take the slope and I flip it. So negative 1/2 becomes a negative 2 over 1, right? And I'll keep the same y-intercept, so that's still an x. So we keep the same y-intercept of 3. So what makes this perpendicular, again, is the slope. I flipped it, and I changed it from positive to negative. So now I go to my 3. I'll do this one in red. So here's my 3. Put it over my blue one. And now my slope is negative 2 over 1. So I go down to 1, 2 over 1. Down to 1, 2 over 1. And again, I'm not the bit. And there we go. That red line is perpendicular to both green lines, actually, because the two green lines have the same slope. And again, we know things are perpendicular where the two lines cross. They form what we call a 90-degree angle. It's a long video, covered a lot in this video. So you can go back and watch it as you need to as you're doing the problems. We'll talk some of this in class as well. But for my in-class students, online students, this is your only version of the class. But practice some problems. Some of you will get lines quick because you understand the tricks. Others you could take a minute, but everything's in this video to help you graph lines. So we talked about standard form, ax plus by equals c. We talked about the quadrants. We talked about how to build a table to graph in standard form. We talked about slope-intercept form, y equals mx plus b, where b is the y-intercept. We talked about the x-intercept. And we talked about how to find slope, y2 minus y1 over x2 minus x1. And then we talked about our last part of the line, our special cases when there's no slopes. We talked about point slope, y minus y1 equals x minus x1 in parentheses. And then we talked parallel and perpendicular. I will stop this video. As always, email me if you have any questions or comment on the video if there's something you need me to correct or change. Have a good day.